More than $71 million is the highest price ever paid for a diamond, enough money to buy more than 200 houses in the state of Texas. So what transformed a tiny carbon crystal into one of the most valuable objects on Earth? Few people realize that behind its brilliant sparkle lies a journey that began deep inside the Earth more than 1 billion years ago. These rare crystals had to survive ancient volcanic eruptions, be searched for among millions of tons of rock, and then pass through a demanding process of recovery, sorting, and craftsmanship before becoming flawless gemstones. Today, join Factron Process as we explore the entire diamond production process and discover why such a small material can hold a value that the whole world desires. For centuries, diamonds were among the rarest and most desired materials on Earth. At the time, the supply came almost entirely from ancient riverbeds in India. As these diamond sources gradually became depleted in the mid-19th century, many people believed the world's most famous gemstone would become extremely scarce. But everything changed in 1867, when a 15-year-old boy accidentally found a 21-carat diamond on the banks of the Orange River in South Africa. This discovery sparked the mining rush in Kimberley and paved the way for the modern diamond industry. Later, De Beers gradually gained control of much of the global supply and launched the "A Diamond is Forever" campaign, turning diamonds into symbols of love and marriage. Today, the diamond industry is worth more than $80 billion a year, with production of around 120 to 130 million carats. However, many mines recover less than 1 carat of diamond from each ton of ore, forcing the industry to mine and process tens of millions of tons of rock every year. Interestingly, most diamonds today are not set in wedding rings. They are working inside oil drilling bits, industrial cutting blades, and many advanced technologies. But before becoming symbols of luxury or tools of modern industry, every natural diamond begins its journey deep inside the Earth. Before appearing in a ring or a jewelry display case, many diamonds have undergone a journey that lasted more than 1 billion years. It all begins at depths of approximately 90 to 120 miles beneath the Earth's surface, where temperatures can reach 2,200 degrees Fahrenheit and pressures exceed 725,000 psi. Under these extreme conditions, carbon atoms gradually bond into a perfect crystal structure, creating the hardest natural material ever known. What is truly remarkable is that many diamonds mined today are even older than the age of the dinosaurs. Their only opportunity to reach near the surface came through rare volcanic eruptions in the distant past, when magma rising from deep within the Earth carried diamond crystals upward and left behind massive kimberlite pipes. Carbon exists almost everywhere on Earth, but only a tiny fraction has ever undergone the extraordinary geological journey required to become a diamond. Before a diamond can be mined, geologists must determine exactly where the ore body is located beneath the ground. They survey areas showing signs of kimberlite, collecting soil, rock, and mineral samples across regions that can span hundreds of square miles. Once a promising area is identified, drilling rigs extract core samples for analysis and the creation of a 3D model of the deposit. However, only about 1% of discovered kimberlite pipes contain enough diamonds to support commercial mining. Because of this extremely low success rate, an exploration project often lasts 5 to 10 years and costs more than $50 million before the first diamond is brought to the surface. Once the ore body has been identified, mining operations begin with massive drilling machines. Drill bits ranging from several inches to more than 1 foot in diameter are driven deep into the kimberlite, creating hundreds of boreholes arranged in a carefully calculated pattern. Depending on the mining level, each hole may reach depths of 30 to more than 60 feet. Industrial explosives are then loaded into each borehole. Instead of detonating simultaneously, the blasts are triggered in millisecond intervals. This method allows the rock to break in the desired direction while reducing ground vibration and minimizing damage to valuable ore. Within seconds, kimberlite blocks weighing more than 1,000 tons are fragmented into pieces small enough for transport. After the blast, the massive piles of kimberlite are quickly collected by excavators and loaded onto mine haul trucks. Each truck can carry up to 265 tons of ore and continuously travels between the mining area and the processing plant 24 hours a day. Upon arrival, the entire load is dumped into receiving hoppers within seconds before entering the conveyor system. This is the link that maintains a continuous flow of ore from the mine to the processing line. From the receiving hoppers, the kimberlite freshly extracted from the mine enters the first stage of processing. Feeders deliver the rock into a primary crusher, where large ore blocks are broken down into smaller pieces, typically measuring about 4 to 6 inches. After primary crushing, the material continues through conveyors and water spray systems to remove clay, dust, and mud from the surface. The rock is then sent onto vibrating screens, where it is separated by size. Oversized pieces are returned to the crusher, while properly sized material proceeds to the main processing line. At large operations such as Ekati, the entire system can process around 7,000 tons of kimberlite per day. Although diamonds rank 10 on the Mohs hardness scale, they can still crack or fracture when force is applied in the wrong direction. For this reason, processing plants do not crush the ore aggressively. Every stage of crushing, washing, and screening is designed to bring the material to the most suitable size for the recovery of rough diamonds. After crushing, washing, and screening, the kimberlite stream enters the recovery section, where the plant begins reducing millions of tons of rock into a much smaller volume of material. At major mines such as Jwaneng in Botswana and Venetia in South Africa, the system can process up to 4.35 million tons of ore per year, equivalent to nearly 12,000 tons per day when operating continuously. The material first passes through dense media separation systems that remove most of the waste rock. Heavier minerals, including diamonds, are retained as concentrate, a material stream far richer in diamonds than the original ore. The concentrate then moves through modern X-ray transmission (XRT) sorting systems. Some XRT units can process approximately 150 tons of material per hour. When a diamond passes through the scanning zone, sensors detect its unique signature and trigger a burst of compressed air that ejects the stone from the material stream in an instant. Thousands of tons of rock are ultimately reduced to a very small quantity of precious crystals. These newly recovered rough diamonds do not immediately become gemstones. They are washed, dried, and passed through optical scanning systems that record their size, weight, and crystal shape. Specialists then examine the most promising stones under 10 times magnification to identify inclusions, fractures, and clarity characteristics. This is where the true value of each stone begins to emerge. Surprisingly, only about 30% of production has the potential to enter the jewelry market. The remaining 70 to 80% becomes cutting tools, drill bits, abrasives, and other high-performance industrial products. In other words, most diamonds mined around the world never appear in engagement rings or jewelry displays. They quietly work inside factories, construction sites, and some of the harshest drilling environments on Earth. After sorting, the most valuable diamonds are sent through laser scanning systems and 3D scanners. These systems record the external shape of the stone while identifying inclusions and fractures hidden within the crystal. Using this data, software creates a complete 3D model and generates dozens of possible cutting plans. Specialists then select the optimal option to balance value, size, and overall quality. Before the first cutting tool ever touches the diamond, nearly the entire manufacturing process has already been simulated and calculated on a computer. Once the cutting plan has been approved, the rough diamond is secured in a specialized holder and aligned according to the crystal orientation determined during the planning stage. High-powered laser systems then create the first cuts, removing inclusions and unnecessary material. The diamond then moves on to shaping. Two diamonds are positioned opposite each other and rotated at speeds of approximately 2,000 to 3,000 RPM, gradually grinding away the edges. This is one of the few materials in the world capable of machining itself. The process also generates the greatest material loss. A 5-carat rough diamond often ends up weighing only 2 to 3 carats before polishing begins. However, the removed material is recovered and reused in industrial cutting and drilling tools. The diamond emerging from the shaping stage already resembles the final product, but it still lacks the signature brilliance for which diamonds are known. To create that effect, the stone must undergo faceting and polishing. The diamond is mounted onto a dop stick and rotated at carefully calculated angles. Craftsmen bring the stone into contact with a polishing wheel coated with diamond powder and spinning at 2,500 to 4,000 RPM, gradually removing extremely thin layers of material. For the most common round brilliant cut, which features 57 or 58 facets, this process may be repeated hundreds of times. Once the facets are complete, each surface is polished to a near mirror-like finish. These facets control the path of light within the stone, creating the famous sparkle associated with diamonds. As a result, two diamonds of the same weight can differ dramatically in value, simply because of the quality of their cut. After hundreds of cutting and polishing operations, the diamond has finally reached its finished form. Before entering the market, it must undergo certification to determine its value. Specialists use 10 times magnification loupes, microscopes, and optical scanning systems to evaluate the stone according to the 4C standard: carat weight, color, clarity, and cut quality. Once the results are confirmed, a unique identification number is laser inscribed onto the diamond's girdle for traceability. In the jewelry workshop, the stone is mounted into a ring setting or pendant using specialized tools under magnification. Metal prongs are pressed around the diamond to secure it in place before the entire piece is polished one final time. Only then does the billion-year journey of a carbon crystal come to an end, in the form most diamonds are ultimately destined for: a finished piece of jewelry. For most of human history, diamonds were something people could only mine, not create. But that is beginning to change. Today, HPHT and CVD technologies allow laboratories to grow diamonds in just a few weeks. In terms of crystal structure, hardness, and chemical composition, they are nearly identical to natural diamonds. By 2024, lab-grown diamonds accounted for more than 20% of the global diamond jewelry market. Yet as diamonds become easier to create, the value of natural diamonds becomes increasingly tied to their origin. A laboratory can replicate the conditions that form a diamond, but it cannot replicate a journey that lasted billions of years deep within the earth. And perhaps that is what continues to make natural diamonds special. A 1-carat diamond weighs only about 0.2 grams, light enough to sit on the tip of your finger. Yet behind that tiny crystal lies a journey that began more than 1 billion years ago, deep beneath the Earth's surface. There, carbon atoms were exposed to immense heat and pressure before being carried upward by ancient volcanic eruptions, eventually becoming trapped inside kimberlite deposits waiting to be discovered. Long before a diamond reaches a jewelry store, humans must first search vast areas covering hundreds of square miles to locate a viable deposit. Millions of tons of rock are then drilled, blasted, mined, crushed, and processed to recover a small quantity of rough diamonds. Those crystals are scanned, sorted, cut, shaped, faceted, polished, and carefully graded before finally becoming finished gemstones. Perhaps that is the true source of a diamond's value. Not simply because it is rare, not simply because it sparkles, but because every stone is the surviving trace of an extraordinary journey that combines billions of years of natural history with some of the most advanced technologies ever developed by humans. If this journey surprised you, be sure to subscribe to Factron Process and let us know what impressed you most about diamonds.